So, you've read the rules, you've had a look at your team. What do you want to do next to be able to look at what you need to do? Well, you've read the rules. What are your targets? What have you taken from that? You know the size of the event. You've got lots of good data from your previous car, so you can make some assumptions of what the targets need to be. So, first of all, actually start planning your design. Don't go into crazy detail. You don't need to solve every nut, washer and bolt from the very start, but you do need to have an understanding of what sort of size the battery needs to be, how much energy you need to store, what system voltage are you going to choose. Often that's going to be driven by the motor and the inverter, which have to operate together. You have to choose a motor and inverter and what voltage you'll need to support the one that you're able to get hold of, the one that you want to use. That inverter will probably determine what system voltage you want to work at. The rules do limit the amount of system voltage that you work at for your safety, so that we don't end up with 1,000 volts like F1 and Formula E. But at the same time, you do need to remember that higher voltages do come with different demands. You have to have better insulation demands, and they have to have better ways of controlling and regulating the current around the device. So look at the voltage, look at the inverter, look at the motor. This is a system, and it has to work end to end. So take a good look at that, and then you can start making some assumptions. What power do you need? What currents are you likely to be running? What voltage? How much cooling? I definitely suggest that you should end up with a really good simulation. So put a team to work, taking your race data from your existing petrol car, and then coming up, you've got all the MathWorks tools right there. You can get hold of them from Formula Student, from MathWorks. Get a good sim running of your powertrain. You can do that in Simscape. You can look at electrical powertrains and battery simulation. Get somebody working on that and make sure you understand what it is you need to do. Simulate everything before you specify anything. In fact, use the simulation to make the decisions. Read the rules. You should come up with some constraints, do some simulations based on your existing data, and you should come up with some directions. From those constraints and those directions, you should then have a set of requirements. That's essentially your targets. What is it you want to achieve and how you're going to achieve it? So once you've gone through that, you should know roughly what size your battery needs to be, because that will determine the energy that you need to be able to finish the endurance at a competitive pace. You should know what voltage you're going to run. You should have a rough idea of what inverter you want to use and how it will communicate with it. And then from there, you'll have a rough understanding of which motor you want to use, what sort of power, how you're going to package it. Do you want one? Do you want two? I would suggest that if you're a first team, you definitely want to start with a single motor and a Drexler diff. Don't go complex, don't go torque vectoring, keep it simple, stupid. It's a rule we should all live by.